engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
hello. Welcome to the show where we bring you the latest breakthroughs in science, technology and medicine. With me, Katie Haler.
And with me, Chris Smith, coming up as England embarks on a multi-billion-pound healthcare redevelopment initiative. What, we're wondering, should the hospital of the future look like?
Plus, we reflect on the recent UK lockdown anniversary and crunch a chromosomal conundrum in our question of the week.
The Naked Scientists podcast is powered by ukfast.co.uk.
This week, as COVID-19 cases continue to fall across the UK, they are at the same time surging in Europe, partly as a result of the spread of the Kent variant that is now becoming the dominant circulating strain of the virus in many EU countries. The other factor is low levels of coronavirus vaccination that have so far been achieved across the EU bloc. Some of that stems from scepticism in EU countries about the effectiveness of the AstraZeneca vaccine. So maybe that will be about to change now, thanks to the announcement of another successful trial of the vaccine, this time in the US.
AstraZeneca have slightly revised their numbers since they made the trial results public, but they're still very encouraging. Chris spoke to University of Kent virologist Jeremy Rossman to hear his reaction, but first asked him whether, a year on from the UK first entering a lockdown, he expected us to be in the situation we are today.
Absolutely not. There's a lot that we had an idea of what was coming in terms of the severity and the need for strong action. But the fact that we are still experiencing lockdowns, that we've spent a large portion of the year in lockdown, in dramatic restrictions, and that we still do not have a solid plan of how we are going to get out of this is really beyond belief to me.
What did you think would happen this time last year when we watched Boris Johnson deliver that press conference when everyone was just glued to the TV and we all felt a shiver go down our spines? Where did you think it would end and when?
I wasn't sure. What I was hoping was that we would have a lockdown and that would drive cases down. Now that absolutely did happen. But what I had been waiting for that didn't happen was that we would use that period of time to build and reinforce the infrastructure needed when we got out of the lockdown. So that robust and functional test, trace, isolate, support system. And then coming out of the lockdown, really gradually ease until we were sure the infrastructure was working to identify cases and outbreaks, and then have a low level of cases. That was what I was hoping for. I was fearing that we would come out too fast and the infrastructure wouldn't be in place and that cases would go up, but I did not expect to have so little functional infrastructure in place for cases to go up so high and then to go into another lockdown.
Do you think we're ready now?
No. Unfortunately, I wish I could tell you something different, but right now I am extraordinarily worried that we are facing exactly the same situation that we faced several times over this past year, that we are going to ease lockdown and that cases are going to start to rise. We still don't have really good infrastructure, and the reliance right now is on the vaccines.
We got a bit more information this week, though, about one of those vaccines. That was AstraZeneca's vaccine, which was a trial from the US. So what do we get from that trial in America? What can we take away from it that we couldn't have known already?
So I think that there are three very important takeaways from this. The first is that AstraZeneca is still a very good vaccine. 79% efficacy at preventing symptomatic COVID and 100% efficacy at preventing severe COVID hospitalizations and fatalities. The second thing is that this clinical trial included a significant number of people that were over the age of 65, because we wanted to make sure that we got good, robust data that, in fact, this vaccine does work well in the elderly. The final takeaway is that there's a real tendency to look at numbers and say, oh, this is 79% efficacious, and this vaccine is 94% efficacious, and so this vaccine is better. And the issue is that you can't directly compare those numbers between different clinical trials because they were done in different times, they were done with different dosing strategies, they were done in different populations. So what we need to conclude from this is to say, look, we have more good data saying that this is a very good vaccine, but to not get too hung up on absolute numbers between the different clinical trials.
How do you think this has gone down with the EU, who many EU countries have not been enthusiastic about this vaccine? In fact, some would say they've even gone as far as to trash it reputationally. What should they take away from this?
My hope is that what they will take away from this is that they have added very solid and very good data that, in fact, this vaccine does work very well, is quite safe, and in fact, is very effective in the over 65 age group. And that specifically has been one point that has been really highlighted by EU countries as a real concern about the vaccine. And unfortunately, it's been phrased in very poor ways, saying that it doesn't work in that age group, when in fact, really, they just didn't have the data to say that it worked. So now we have the data. So my hope is that this will help convince people in the EU that, in fact, this is a good vaccine.
Let's hope so. Jeremy Rossman there.
Now, if you're listening to this, chances are you have a remarkably large brain, and that's not just because you're a Naked Scientist fan, but because you're a human. By the time you're born, your brain contains 3 times as many nerve cells as the brains of our close primate relatives. And now scientists from the MRC Laboratory of Molecular Biology in Cambridge think they know why. A gene called ZEB2, which affects how cells move, kicks in later in human brains, giving us extra time to make extra brain matter. The work is the brainchild of Madeline Lancaster, who's here to tell us more. What exactly have you done?
We've used what are called brain organoids. These are in vitro models of the developing brain that we generate from embryonic stem cells. And we've generated these from human stem cells as well as ape cells, and then compared them and looked at their size over time and been able to discover why they're increasing in size in human compared with non-human ape.
Okay, so you looked at these organoids growing over time. What happened then? What did you see?
Well, first of all, we, of course, wanted to look at size because that's what we know is very different about our brains. Our brains are around 3 times larger. We just generated these organoids and compared them and found that the human organoids were indeed about 2 times larger than the chimpanzee and gorilla organoids that we generated.
So what's changing then? What's different in their development? Do you kind of get to a point when you're observing these in the lab and something changes between the two?
Yeah, exactly. So once we saw this difference in size of the organoids, we could actually go in and see what the cells were doing inside. And what we found is that the neural stem cells, so these are precursor cells that will give rise later in time, they'll generate the neurons of the brain, so all the nerve cells of the brain. But what we found is that before they even start making all those nerve cells, the human cells had a different shape than the cells of the chimpanzee and the gorilla. And this shape was indicating that the cells were maturing more slowly. And because they were maturing more slowly, they were actually able to proliferate faster. So that means they were making more and more of themselves more quickly. So they ended up with an increased number of these mother cells, if you will, that once those cells start making nerve cells, you have more of them, so you're able to then generate more of these nerve cells.
Is it a bit like the sort of tortoise and the hare situation? You know, it's taking longer to develop the brain, but you're going to get something, well, I guess we would say maybe a bit better out of it, but maybe that's a bit human-centric.
It is probably a bit human-centric, but I like that analogy, definitely. It's you take a little bit longer with these steps so that you can set up a bigger starting pool of cells. And once you have this bigger pool of cells, then everything that happens after that is going to be increased.
Did you look at why this is happening? What's going on genetically?
So then we compared their genetic signature. So, what genes are actually on in these organoids from these different species. And what we found is that when there's sort of this delay happening in the human, there's also a delay in a particular gene, and it's called ZEB2. And this is a gene that in other contexts, for example, in cancer, has been shown to trigger a change in shape, which is in some ways similar to the change in shape that we're seeing. And so that was really kind of a red flag that really suggested that ZEB2 might be responsible for this change that we're seeing and for the delay that we see in humans.
And can you confirm that by altering ZEB2 and seeing what happens?
Yeah, exactly. So the real test then is to play around with ZEB2 expression, basically. So we could turn it on earlier in the human, mimicking the kind of expression that we see in apes. And when we do that, then we see these cells change their shape earlier than they normally would, just like in the other apes. And we can also do the opposite, where we can perturb the signaling that ZEB2 is doing within those cells and basically delay its effects in the ape's organoids. And then we can see that those cells start to look more like human cells.
This is really cool, but I'm wondering, how much can this tell you about why human brains are different from other apes? Because we're talking about organoids, they're not full brains.
Yeah, absolutely. No, I think that's a really important point. I mean, of course, these are a model. They're a very useful model because we can't do, nor would we want to do experiments, on developing ape brain. And it's very difficult to do any kind of experiments on developing human brain tissue. So this is really kind of the best option we have, but we can compare the human organoids to actual human fetal tissue. And we find that early in development, actually organoids are quite a good model for the developing brain. And so there's no reason to believe that that wouldn't be true for apes as well. And so it's a fairly safe assumption that these findings would probably apply to what's happening in the early brain. But of course, this is really only the very early events. And later on, the organoids do start to diverge from the actual brain quite a bit.
Madeleine Lancaster, thanks very much. And that research has been published in the journal Cell.
To outer space now, and Adam Murphy has been looking at some wine that has been boldly going where no wine has gone before.
Getting an experiment to space and back again is good cause for celebration. The kind of occasion that calls for the opening of a nice bottle of wine. It's doubly good then if that experiment was a bottle of wine, or a dozen bottles of wine. 12 bottles and 320 little vine shoots have just come back from the International Space Station after spending a year in space. The bottles were Chateau Petrus 2000, a wine very much in the bracket of, if you have to ask for the price, you can't afford it. But since you are asking, it's about €5,000 a bottle. The kind that would be wasted on the likes of me, whose preferred wine is whichever one has the sales sticker on it. This is an experiment being run by the Institute of Vines, Science and Wine in France, along with a company called Space Cargo Unlimited. The idea was to see if aging of wine happened any differently in space to down here on the ground. When the space wine was tasted along with some that stayed down here on the ground, some tasters claimed the wine that had been into space tasted younger than the one on Earth, but others still said it was incredibly hard to tell them apart. When I'm given wine, it just tastes of wine, fermented grapes. More data is needed. There is reason to the space wine though. Here on Earth, when wine is just sitting there aging, there will be movement of liquid inside the bottle. It's called convection. Warmer liquid rises up and cooler liquid goes down. This mixes around the oxygen in the bottle, and ingredients reacting with that oxygen are what age the wine. But up in space, up and down don't really apply when there's no gravity. So convection doesn't really happen. So the rates of reaction in the wine can change dramatically. The other half of that was the vines they sent up though, and they all came back down fine. They all seem to have survived and are apparently growing even faster now that they're here on Earth. Which, if I was a plant, I'd rather grow down here than up there. This is all part of an idea to see if you can come up with more resistant vines. You send them boldly going where no grapevine has gone before, and they have to adapt to a whole host of changes that they never would on Earth. And then when they come back, maybe one of those changes also helps them to be more resilient to temperature or disease. Or at least You get a better understanding of how plants adapt, which is helpful for all agriculture really. Although they are just back, so this is just the start of the experiments on both the wine and the plants. And if nothing else comes from it, at least there's some people who can say they got to drink space wine.
And let me guess, the flavour was out of this world, wasn't it? Adam Murphy there.
And if you'd like to find out more about the news stories we've discussed, the links to each of the referenced papers can be found on our website, nakedscientist.com, along with the transcripts of each show for every Naked Scientist episode.
The world is worried about a number of new coronavirus variants. But are they going to be a problem for the vaccine? Biologist Pei Yongxi is working on exactly that.
We think the vaccine still works quite well.
Here's the issue: quite well sometimes means not as well, and we don't know whether that is good enough.
That minimum bar has not been defined.
That and more on February's episode of Naked Genetics, wherever you get your podcasts.
And for the rest of the programme this week, we're going to explore what the hospital of the future might look like. The reason we're doing this is that every year, the Wolfson Economics Prize is awarded to recognise fresh thinking that challenges the status quo in economics and public policy. And it's a big deal. The winner gets £250,000. The 2021 Wolfson Economics Prize is looking for ideas that will radically improve hospital care.
One reason for making this the objective is that England's about to spend £3.7 billion on what is being called the biggest hospital building programme in a generation. But what should be built or changed? These are the answers that Simon Wolfson, who founded the prize, is hoping this year's entries will address and provide a blueprint that could guide the future health service overhaul.
Basically, what we're looking for is ideas as to how to build a hospital of the future. And we're looking to improve absolutely every aspect of the hospital experience, whether that be the patient experience, the clinical outcomes, staff well-being, and the way that the hospital integrates with the healthcare system in its community.
Why are you doing this now?
£3.7 billion is about to be invested in UK hospitals, and a lot of our hospitals are hugely outdated. The thing that concerns me is that we don't just build more of the same or slightly improved versions of the past, but really go back to what a hospital could be and look at absolutely everything from how people feel when they walk in. Do people feel that they're walking into an aesthetically pleasing, calm, well-organized, easy to understand environment? Or do they, as is all too often the case today, walk in somewhere that's extremely confusing, slightly intimidating, where the first reaction you have is one of confusion and fear? How the food is delivered to patients so that it's hot and appealing and well cooked, controlling infection within the hospital through designing the flow of patients, staff, ancillary workers and visitors in such a way as to minimize cross-contamination.
Why does this not exist already?
It's a bit like the old joke about two economists, actually. Two economists are walking down the street. One of them sees £50 on the floor and says to his friend, "You should pick up that £50. And the other economist said, "Well, if that was really £50, someone would have picked it up already." The reality is that innovation and new ideas require some form of stimulus to get government to listen to those ideas and make sure that they incorporate them into what they're doing. So, my view is that a lot of these ideas would probably come to light without a prize, and some of them would be incorporated into new hospitals. But this prize will get more ideas into the public domain and be able to be presented to government in a single document that says, "Here you go, this is what we need."
How's it going to work in practice then? Talk us through the process of the call that's gone out, who you're hoping is going to enter and how they'll be appraised, these entries.
We're looking for people with experience of working or building hospitals to come together and present new ideas. So we're looking at everybody from architects to clinicians to nurses to come up with their ideas as to how we could build a better hospital. The process will be twofold. The first entry is 10,000 words. We'd rather have entries that have got a small number of great ideas than in this first round something that is a comprehensive hospital design. The judges will then come up with 5 finalists, and those 5 finalists will then develop their ideas into something much more comprehensive. We're looking for around 25,000 words. We're hoping to have a winner announced in November.
Is there a partner in this, though? Because obviously it's wonderful to stimulate this sort of thing, get these ideas flowing, bring teams together and come up with some really very exciting and innovative ideas. But will it just peter out after that?
There's definitely the perfect partner, and the perfect partner is the NHS. And what we're hoping is that by introducing this prize, wherever a hospital is being built and whoever's responsible for it, there will be this winning entry where they can, in one place, see all these fabulous ideas laid out very clearly, well explained, affordable.
And is it just the UK you're thinking about, or is the idea really that you could have a fantastic model that you could translate anywhere?
Our objective is absolutely that this is relevant around the world. At the end of the day, the clinical problems facing a hospital patient in Asia, Europe, America, ultimately there's the same problem, and therefore the facility in which you're cured will have lots of things in common wherever you are in the world. The reason why we're focusing on the UK and why I think the prize started in the UK is because this country is about to embark on a huge hospital building programme.
Exciting, isn't it? Lord Simon Wolfson there on the Wolfson Prize 2021.
So, what should the hospital of the future look like? Well, for the rest of the show, we'll be gathering the thoughts of architects, clinicians and scientists, as well as patients and staff. For author and cancer charity ambassador Bami Adenipekkun, the atmosphere and environment of a hospital really matters.
As a patient and loved one, I have to say that the current institutional hospital model is one that is not dignifying and is often scary. I would love to see hospitals that recognize the importance of surroundings to overall well-being. The power of intentional architecture and design to alleviate suffering cannot be overemphasized. It humanizes and boosts confidence.
Bami Adenipekkun there. More from her and how we can build environments that meet patients' expectations coming up. But first, one of the biggest challenges to safe and effective healthcare is making sure that patients don't pick up infections while they're in hospital and that they don't bring new infections in with them. Infection control is a major priority now, and even more so since the era of COVID-19. And it's the job of infection control nurse Christine Moody at Addenbrooke's Hospital in Cambridge. Christine, what is the health burden of infection control?
The infection control healthcare burden is absolutely huge. Infection control has fingers in many pies, and we look at absolutely every aspect of a hospital setting. It isn't just about the patient coming into the hospital, it isn't just about the staff caring for the patient. It's looking at the fabric of the in-hospital, the environment, the cleaning practices, the waste disposal, providing safe, clean water, and ensuring that our patients are given a healthy, nutritious diet to eat while they're with us. So there's so many aspects to infection control that really do impact on every little bit of a patient's stay.
So you kind of hinted at it there, but could you just tell us a bit about how infections spread and therefore how you try and mitigate against that? Are there some sort of really key features that you have to focus on?
There is something called the chain of infection, which is really key to sort of helping you think about how patients may get an infection while they're in hospital setting, because it does happen, or whether we can prevent that happening in key areas, or if they do come in with an infection, how we can prevent that being spread to other patients. So something called the chain of infection, and that talks about looking at the different viruses, bacteria and other small microbes that can be spread either from person to person to the environment, and therefore them to other patients or even staff. And it does work the other way, from staff to patients and visitors. So we want to try and prevent that. The good thing about the chain of infection is it has really clear pointers where you can break it. So one of the key things that we can do is wash our hands, ensure that we wear the right personal protective equipment when dealing with patients. Even looking at the environment itself and trying to minimise the potential from patients having contact with one another. And there's something that we do called isolation nursing or barrier nursing.
So how well does this system of tracking the chain of infection and then breaking it at certain points, how well does that work?
It works reasonably well because ideally when a patient comes into the hospital setting and they are clerked in through the accident and emergency, or what we call ED now, emergency department, you get a feel and you'll get a list of things that you can look at and think, right, this is what we think might be going on with this patient. So therefore, if you suspect there is an infection on board, and whether it's something like flu, having just been through the winter season, or a norovirus, which we know are easily transmittable between people, then we want to try and prevent that from happening. So therefore, we would move a patient into an isolation or barrier nursing room. So by putting up that barrier, if they are unwell, the chance of it being spread to another patient is far reduced. Also, then the staff would take the correct precautions, so good hand washing, making sure that they put their apron and gloves, all the things that you see nurses wearing, and doctors as well, before they're going in to see their patient. When they deal with their patients, to make sure that they're safe and clean and comfortable, then removing that, so we call it doffing, their aprons, their gloves, and disposing them and then washing their hands again. So it's about trying to break the potential for spread.
What would you like to see in a hospital of the future with regards to infection control?
So if I had my infection control hat on and I was able to design a brand new hospital, it would be all side rooms, all with en suites, actually have showers, toilets, and have every piece of equipment that I potentially could need in that room itself. By having the fact that normally in a normal ward, you can see patients in a bay all together, and they can see the nursing staff and the doctor staff and the cleaner. Unfortunately, with a side room, it does mean that that is quite difficult. So having the technology to be able to sort of, almost like we're doing now, having a Skype call, being able to at least call a member of staff and have that visual would be a really great thing. To have your equipment for all your monitoring that you needed, being able to make that stay for that patient as comfortable as possible, because one of the things with this isolation nursing is some patients take to it very well. They like the peace, they like serenity, and others do not. Others miss that communication with other patients and having a bit of support that way. So we need to make these rooms as comfortable and as home-like as we possibly can, without obviously making it difficult for us to clean. We need to make sure that the environment is as clean as possible so there's no spread of infection.
Christine Moody, thank you very much.
No, it's not just infection control that would benefit from reformatting of hospital spaces. The working environment itself could improve considerably, as one nurse told us.
It would be important to reevaluate the actual structure of the hospitals when they're made so that they're fit for purpose. For example, our growing population of people and patients growing in size means that space is an issue and causes tremendous pressure from a logistical point of view. It can be difficult to treat a bariatric patient in some areas because the equipment required can be overwhelming. The requirement for side rooms has proven a necessity, particularly in the pandemic due to airborne viruses. The unfortunate patients who have been infected and those that need protection from the virus are at risk. Therefore, I would suggest a generous size hospital with more than needed side room space, but more importantly, with specialty-specific areas so that specialists can treat the patients effectively.
So, how can we surmount issues like these? Well, that comes down to designing buildings that are fit for purpose, and that is the job of architects like Cambridge University's Alan Short. And he's also very interested in how air flows through hospitals, particularly in the wake of the respiratory infection that we're all enthralled to at the moment, COVID. Alan, if I were to take Florence Nightingale from 100 years ago plus and transport her to one of our wards today, I don't think she would actually feel that out of place, would she? I mean, what she would see would be pretty much familiar to her.
Well, I'm not sure about that, Chris. I'm looking at her 1858 Liverpool lecture, which changed hospital design in Britain, and she wrote, "Natural ventilation is the only means of procuring the life spring of the sick, fresh air. No artificial ventilation can do that." And in the article, there are plans of bad hospital wards, which are deep plan and can't be cross-ventilated. And I think she'd see quite a number of those.
What I was getting at is that we don't do what Christine Moody was just saying, which is give people their own space and their own air, and therefore their own opportunity to keep themselves away from the sources of infection that you see coming from, inevitably, contact with others. And what we probably need to be striving to do is to actually do that in order to keep people separated as much as possible where appropriate, so that we don't get cross-spread of infection between patients, but also critically between staff and patients.
Well, I was very interested to hear Christine say that, because Professor Roger Ulrich came over from Texas A&M perhaps 12, 14 years ago and persuaded the Department of Health that hospitals should be like hotels where every patient has their own room. But there are quite interesting implications to that, particularly the population of hospitals becoming older and older, people with dementia. We spent a lot of time in the Bradford Royal Infirmary, which is a classic Nightingale hospital, and the staff there were very pleased to have their older patients gathered in Nightingale wards. And you can redesign them, make them much nicer and give everyone privacy. We have a zigzag plan, which the Cabinet Office called business class for the NHS. So one can think a bit more laterally, I think.
Let's look at the ventilation for a second, because that arguably is key, isn't it? Especially when you've got respiratory infections like coronavirus, but also like the flu, which is a scourge every winter, and things like norovirus that causes winter vomiting disease. Although that is not a respiratory infection, air currents carry it round and lead to explosive outbreaks. How can we use ventilation to try to mitigate against some of those threats?
The enthusiasm for making artificial environments in large public buildings now is very problematic, actually, because mechanical airflow systems that push the air in at the top and take it out mix and churn the air. That's part of the idea, to save heating energy, but it's pretty disastrous in terms of spreading pathogens around a ward or indeed in an operating theatre.
So how could we do it better?
You know, the NHS has to be zero carbon by 2050. We're very interested in reviving what was a fantastic art and science of natural ventilation. You can enhance that with some mechanical help, but our interest is in recovering all of this lost knowledge, and you can see it disappearing in the waves of hospital building since the last Nightingale hospitals were built in the late 1930s. As matchboxes on muffins towers and other high-rise slab buildings so on become completely artificial in their environments. This is highly problematic and not really necessary, certainly not in England.
But what do you have in mind? What do you envisage would be the solution, and how does your strategy work? And rather than just drop a cheque for £3.7 billion and hope for the best, how do we do something that we know is going to be money well spent?
My colleagues and I have designed an imaginary, very, very low carbon hospital for the Department of Health. They'd set a target of 35 gigajoules per 100 cubic meters, and they didn't know whether you could make a hospital that would achieve that.
How does that compare and contrast with today then?
Oh, well, Addenbrooke's is about 104, 107 gigajoules. So it is a massive reduction in energy consumption. But we have a nice scheme for Addenbrooke's, which is to stack ventilate all of the floors and to cross-vent them. So organised natural ventilation. Of course, a big problem with hospitals is they overheat in the summer, and mechanical ventilation systems can't deal with that, and they have a much better chance of calming the environments if you naturally ventilate them.
Can you just explain to me how this actually works physically, though? What would you have to employ? What would you have to install in order to have what you're envisaging actually working?
The most interesting scheme for the tower puts another elevation, a facade, on top of the one that's there, shades the windows because there's a huge solar gain problem, and it connects each floor to a series of stacks that go right up to the top of the building, and you just use the natural pressure differences, the top to the bottom of the building, to drive huge amounts of air through the building, and we've modelled that rather carefully, and it looks very promising, and this is really no energy at all expended in venting the hospital.
So not just hot air, it could become reality. Thank you, Alan, very much. We'll hear more from Alan later on in the programme, so stay tuned.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound. Perfect music for audio and video productions.
And today we're asking, what should hospitals of the future look like?
Well, critical to the functioning of any hospital are the staff. And too often when budgets are tight and space is tighter, staff well-being and the productivity benefits of a pleasant working environment can be overlooked. Mary Dixon Woods is a social scientist. She directs the This Institute that works to improve the scientific evidence base that informs how we improve healthcare. So, Mary, is it true that happy workers deliver more productivity and better care? And if so, why doesn't it get higher priority?
There's very much a relationship between quality of care and outcomes and the well-being of staff. Why it doesn't get the attention it possibly deserves is linked to the challenges associated with producing an evidence base for how you do improvements, and linked also to the level of investment that's needed in it.
Okay, so what evidence do institutions like yours have for what people who work in hospitals want from their future workplace?
We've actually got a really clear evidence base. They want clear goals. We know that teams function much better when they're very clear about what they are trying to achieve. We also know that teams in the NHS often aren't optimised in that respect. A second thing that they want is really good management systems, actually. So functions like human resources need to function really, really well. So staff know that their well-being is taken into account in planning. They know things like rotas and annual leave and occupational health are well planned. They want appreciation and respect, as we all do. They want respect particularly for aspects of diversity. And they want opportunities to contribute to improvements. And they also want, very importantly, to work in well-designed operational systems.
Tell me a bit more about the actual buildings. What about space for, say, somewhere to take a break?
That's very important. We've discovered this repeatedly, that having a space to take a break is very important for all kinds of reasons. Some of them are to do with addressing fatigue, which is a major problem in hospital workers. Some of it is actually social, and the opportunity to create connections with your colleagues is a very important part of team building. It's also very important to patient safety, because this is an opportunity to create informal learning opportunities, to share knowledge, and often to anticipate problems and trap them in relation to individual patient care.
So how do you know all of this? What kind of evidence can you gather, and how do you do it?
We can use a whole range of techniques. Sometimes they are surveys of staff, and the NHS has been running very successfully for a number of years the NHS staff survey, which tells us an awful lot about what matters to staff and how well their needs are met. We can also use time and motion studies, and these directly observe staff as they're going about their daily work. And we can identify, for example, how often they're interrupted. And I can tell you nurses are interrupted every 6 minutes. We can tell you how much of their time is wasted on operational defects, and that's about 12% of their time. So huge opportunities for addressing frustration and time waste there. And we can use trials, we can use experiments to assess what kinds of interventions seem to make improvements. We can also learn a lot from industrial technique, including in particular engineering, which is very highly skilled in analysing and improving work systems.
So is that sort of applying an engineer's mindset to tackling some sort of process?
That's right. So we would often use social science techniques to analyse where the weaknesses might lie in a system and what matters to the people involved. So it's very important to build a vision of what good looks like from the perspective of patients and staff. Engineers are very good at using techniques, particularly in a discipline called human factors, which combines engineering, psychology, and a number of other disciplines into design of solutions that are well suited to addressing the problems that we can identify. And some of that will be to do with physical design, designing systems, as you were talking to your colleagues earlier, for example, ensuring that you've got smooth processes for, say, delivering medications, smoothly operating equipment that minimises infections. Other times it will be to do with improving teamwork, communication, and other processes that rely on human interaction.
Is there anything else you think that the hospital of the future should look like in terms of being a workplace?
I think the hospital of the future should be constantly seeking to improve, constantly learning from its own staff and its own patients about what good looks like, how to make those improvements through continuous experiments and rapid cycles of change.
Mary Dixon Woods, thank you very much.
I put a call out on social media earlier today just to ask what people thought about their vision for the hospital of the future. Interesting what Mary was just saying. X-Ray Training on Twitter said some decent, healthy cooked food from a canteen on a weekend. Very few hospital canteens actually offer opening at weekends. Instead, we have naff, as she says, naff, expensive sandwiches from the hospital shop. Dr. Gavin Sullivan, an anaesthetist, says more rooms with windows that look out onto greenery. The hospitals of the past used to have day rooms that patients could sit and chat in. Turns out that was in the future. Yes, we'll look at some of those social factors a bit later in the programme. And Imran Khan says invest in artificial intelligence that can more effectively integrate and analyse data sets and incorporate new research to arrive at best courses of treatments. Well, perhaps we're actually going to go in that direction right now, because the next thing on our agenda is to consider one of the biggest, arguably, revolutions of recent decades, and that's the introduction of computer systems and IT, which will open up, we're told, opportunities to streamline healthcare and to marshal big data. Afzal Chowdhury is the Chief Medical Information Officer at Cambridge University Hospital's NHS Foundation Trust, which was, importantly, one of the first hospitals in the UK to go fully electronic, online and paperless. Afzal, what are the promises of this sort of technology? What can we do with it?
The implementation of hospital-wide electronic patient records are really able to bring benefits in a whole range of domains. If you think about ever-increasing high-quality care, then the properties of that are that care should be safe, timely, efficient, effective. It should be equitable, it should be patient-centred and sustainable. And we know that technology is able to really help in all of those areas.
How? What's it do that we couldn't do with doctors' admittedly terrible handwriting and paper notes like we had before?
Increasingly, medicine has become more and more complex, and there are a whole myriad of interactions that any given patient might have with their NHS in its widest sense. On a sort of daily basis, every 36 hours, there are more than 1 million patient encounters with the NHS as a whole. We know that technology helps with safety, for example, supporting clinicians in making decisions. It can also help in terms of good prescribing, reducing unwanted variation, and it makes coordinated care much, much more straightforward.
Very expensive, these systems, aren't they? The system that you've implemented at Addenbrooke's Hospital did cost hundreds of millions, and in that sort of ballpark you could employ large numbers of staff. So are they actually value for money?
It is true that there's a cost to implementing these systems. In fact, the majority of the cost for us at Addenbrooke's was related to infrastructure, making sure that all of the computers were modern, that there was a hospital-wide wireless network, and also a lot of work around device integration, so connecting all of our physiological monitors and ventilators to the electronic patient record system. But it is true that those systems do cost money. But the counter to that is that what we're doing with paper-based systems is also incredibly expensive. We used to employ a lot of staff who were managing the paper records, putting in the library, retrieving them. We know that paper records were on occasions lost, and that was really diminishing the quality of patient care. And we also know that across a whole range of domains, nurses, for example, were spending a lot of time trying to track down what it was that the doctors wanted to do, or transcribing information from one piece of paper to another piece of paper. And all of that, when you multiply it across the domain of a single hospital and then across the NHS as a whole, is incredibly inefficient and expensive. So I would argue that the cost of not doing this is actually worse than the cost of doing it.
And Imran's point that actually we should be looking at AI, he's getting at using various ways of marshalling big data. Presumably having everything in one place electronically, very consistently and homogeneously recorded, does make doing original research, follow-up, side effect monitoring and so on much easier.
Absolutely. So even at Addenbrooke's, which is just one hospital, in any given month we're recording over 170,000 new diagnoses on our patients, about 3.8 million results on our patients. And what you can see is that consistency of data, that accuracy of data, the timeliness of it on a significant number of patients from routine clinical care is immensely valuable. The data, for example, from Israel related to COVID vaccination has proven to be really, really important. Has been one of the really early examples of the success of the vaccination program, and that is really relates to the fact that they have a strong, consistent model of recording information on every patient that's used for the betterment of all.
if I could write you a cheque that would buy you some wonderful equipment or IT infrastructure for the hospital of tomorrow, what can you not do at the moment that you wish you could?
I think really what we want to do is to really invest in supporting our patients. So patient empowerment through transparency and access to their own data. I think remote monitoring of patients, whether in the hospital or at home, to get a better understanding of both their physiological parameters and their day-to-day routine, combined with that high volume of data that we get through consistency, means that we'll be able to really move towards a position where we'll be able to deliver more personalised care for patients based on their own activity, their own physiological parameters, their own clinical baseline. And that means we'll be able to detect disease at an earlier point in time, and that means that often the treatment will be more straightforward and more effective.
Let's hope so. Afzal Chaudhry, thanks very much for joining us.
So far, we've considered the Hospital of the Future as a building, an information hub, and a workplace, but ultimately hospitals exist to treat patients. So what's missing at the moment and what needs to be prioritised? Here's Bami Adenipekun.
Careful thought and planning need to be given to ward layouts to accord patients confidentiality as well as privacy when needed. The design of patients' hospital wear needs to take into consideration movement outside of consultation rooms to afford a modicum of dignity. As infection control has become a vital issue, food handling requires a rethink as well. Bottom line is that a one-size-fits-all approach does not serve patients and their loved ones well. As hospitals exist to treat people, constructive engagement with their representatives should be reflected in overall structure and design. Hospitals are for patients, not the other way around.
All very pertinent considerations. And to tell us what else could be done to improve how patients feel in hospital and potentially speed up their recovery or ease emotional tensions, I spoke to Evangelia Chrysikou. She's an architect and medical planner at UCL.
In my own research in psychiatric hospitals, very frequent patients complain about noise from doors. They are heavy. If you are in a ward, you can hear many doors. People don't think very much of the surfaces. Surfaces are thought as an aspect for infection control. We don't consider, for example, that it could be surfaces that they could absorb noise. We have these technologies. We do these things in other contexts. There are technologies that could be used, low-tech and high-tech.
So noise is one. What about light? Have there been studies done to assess how much light someone can tolerate if they need to go to sleep or anything like that?
Light is something that, in general, it is relatively well studied. Light can be positive or annoying, depending also where the light source is. It can be managed by where we place the source of light, but also what type of light we have. If we can adjust, for example, elements in the room, like if a hospital room could have curtains that maybe the patient could control. If, for example, we have the discussion about individual and shared patient rooms where, again, there is the control aspect can be different. If you give to the patient the opportunity to control the light, this is around the bed, but also where the light sources are in the corridors. For example, this was most frequent in the past, that the hospitals would have the light in the middle of the corridor, and then you would have people looking at these lights when they were moved around the hospital. Now, this is something that designers take a better consideration, for example, but in general, it can have a therapeutic effect, also natural light. This is an area where we have very good evidence. There has been a study on recovery, and we have seen that patients who recover in post-operation rooms, that they have windows with natural light, as opposed to people who are in dark rooms, artificially lit. The people who are in the natural light area, they have faster recovery. And this is very significant because it means that you need less pain medication, for example. They occupy the bed of that area less time, but it's also very important for the patient to leave the hospital or specific areas of the hospital to move to more relaxed spaces as soon as possible.
You've mentioned light and noise, but what about decorations in a room?
in all of this comes the element also of control and the ability of people to intervene in their environment. This has a positive effect when people can control their environment. We have evidence when they can control temperature, for example, or as I said, the light. But with decorations, there was a study done in the US where they used the pictures of the Amazon catalog. They classified the images according, for example, images that were more abstract, more naturalistic, photographs of nature, sea views, or savanna. They looked what healthy people liked when they live in their homes and what patients really liked when they are in the hospital. And they found that the two groups differ significantly. Patients in hospitals, they liked naturalistic images. They were not fond of abstract art, and they liked images of nature. Savanna was their preference, which is something that, of course, you don't expect to see in people's home, where you have more variety and more different types of art. But this was a very good study, actually.
Are there any other really key areas where research suggests that designers can intervene to make the experience of being in hospital a bit better?
Yes, for me, the control is a very important element. When the patient enters a hospital, they lose a lot of things, and one of them is their choice and their personalization. A lot of decisions happen for them. It's important to have a sense of control. This is something that is not only for patients. We have evidence for that for all people. But everything that's applicable to normative people is more applicable when people are not well.
Evangelia Chrysikou.
Mary Dixon Woods and also Alan Short are still with us. Mary, just listening to that, it seems like it's almost research into the blinking obvious, isn't it? These are all things that we would all ourselves absolutely love to see if we were in hospital and would not want to have doors banging, lights on all the time, lights blinding us as we get wheeled down corridors, but we still do it. What else would you like to see change about the hospital of tomorrow?
There are lots of design issues to be resolved. As you say, many of these priorities for patients are evident, but how you resolve them is not as straightforward as it might appear. Also important to patients are fundamental processes of care. We know, for example, about 20 to 30% of patients admitted to hospital develop delirium, which is a very upsetting and frightening condition for patients where they become acutely confused. We know that that can be managed or prevented to some extent by processes of care like good hydration, good diet, pain control, avoiding constipation. To deliver all of those processes, to make sure people reliably get the care that they need, you need to have enough staff, and that's absolutely key. And you need to have processes that enable staff to do what they need to do.
Alan Short, is this all feasible given the constraints of the building architecture that we have within the NHS already? Because the NHS is a huge landowner, isn't it? And has a huge number of assets that effectively all would need to be retrofitted and updated to meet some of these expectations.
Yes, well, we measured 627 buildings across England, and the bill we came up with was about 17 billion. It's entirely possible to rescue these buildings. I think the challenge for designers is how to achieve the dignity and humanity in the spaces that your previous speaker spoke to. And I think that's about designing very characterized and specific places and buildings, not huge gridded slabs, contemporary prototype for a hospital.
I'm surprised it's actually so low. 17 billion, I know that is about 6 times bigger than what they're currently planning to spend, but given that is the whole lot, that's not that much.
It's not that much because the backlog maintenance bill in the NHS between 4.5 and 5 billion a year. Yes, it's about 5 years. Normal maintenance cost. It's entirely possible.
Well, on that optimistic note, we will leave it there. Alan Short, thank you very much. Thanks also to Mary Dixon Woods and to our other guests this week, Afzal Chowdhury, Christine Moody and Evangelia Chrysikou.
Now, to Question of the Week, and listener Matty has been in touch with a curious question about chromosomes, which Eva Higginbotham has been looking into.
If humans have too many or too few chromosomes, it can cause them to be infertile. So how did different creatures get different numbers of them? For example, humans have 46 chromosomes, but mice have 40.
It's It's an interesting question. How did changes in chromosome number ever occur if they can cause the individual to not be able to breed to pass on those changes to the next generation? I put the question to Hugues Rost-Crolius. He's an expert in genome evolution at an institute in Paris.
It is true that in humans the total number of chromosomes is 46, and any change can lead to adverse effects, such as in the case of Down syndrome, caused by an extra chromosome 21. However, during evolution, chromosomes slowly evolve and exchange pieces, and they can also fuse or break.
These changes can happen due to mistakes during meiosis, the genetic process by which we divide up our DNA to make eggs and sperm. Importantly, not all mutations in chromosome number result in infertility, as long as the chromosomes haven't changed so much that you can't make any viable eggs and sperm anymore. In fact, it's these changes that can trigger the formation of a new species.
Starting from a common ancestor, after millions of years of this process, two species can end up having very different numbers of chromosomes. For example, the ancestor of placental mammals lived about 100 million years ago, and we think that it had 46 chromosomes. Today, one of its descendants, the Indian muntjac, a species of deer, has only 6 chromosomes, while dogs, another descendant, have 78.
In fact, scientists think it was a fusion of ancestral chromosomes that created the human chromosome 2, and that this could have been an important part of separating us as a species from our close relatives, the chimps, apes and orangutans, who all have 24 pairs of chromosomes to our 23.
The chromosome number can therefore vary quite widely, showing that it is not so important. What is important is the total number of genes that they carry. All mammals, humans, mice, dogs and Indian muntjacs included, have about 20,000 genes on their chromosomes. The many small dog chromosomes carry few genes each, while the few large Indian muntjac chromosomes carry lots of genes, meaning that they both have about 20,000 genes in total. This number of genes is important to carry out all the functions required for the typical mammalian organism.
Given this, it's easier to understand why an extra chromosome 21 causes Down syndrome. It's not so much the extra chromosome by itself, it's all the extra genes that it carries that causes the disease. And importantly, about 30 to 50% of women with Down syndrome are fertile, and some men with Down syndrome have fathered children too. Thanks, Hugues. Next week, we'll be looking into this question from Nancy.
Why does chili stay on your fingers for so long after cooking with them? Even after you wash your hands multiple times, it can still hurt if you touch your eyes.
Know the answer? Well, if so, why not join in the debate on our forum at nakedscientist.com/forum. You can also email it to us together with any new questions to chris@thenakedscientist.com. There's also an online form you can use on our website, nakedscientist.com/question.
That's it for this week on The Naked Scientists. Next time, it's the strange story of cryptocurrencies. If bitcoins make your eyes cross and blockchains set your head spinning, this is the show where we'll demystify the lot, plus psychology, crypto art, and is the bubble going to burst? The Naked Scientists comes to you from Cambridge University's Institute of Continuing Education and is supported by Rolls-Royce. I'm Katie Haylor. Thanks very much for listening, and goodbye.